First of all, I want to thank everybody for taking time out of their busy webinar. Over the years, we've had some very positive feedback on this. One of the things I will say is that I typically will see the same names over time repeated on the list of attendees for this, because there is so much information that it's really hard to absorb it all in one sitting. So definitely, by all means, come back, watch it again. We also have a very close proximity to this webinar on demand at aiaspec.com. So sometimes you can pick up some additional things that are said there, maybe a little bit differently. And then at the end of the day, we're here to answer your questions. So by all means, please don't hesitate to call us. My name is Jason Spangler. I'm the flooring division manager here at Wagner Meters. I'm responsible for not only the concrete side of stuff and moisture measurement, but also the small line of hand meters that we have for wood floors, wood subfloors, things along those lines. My direct contact information is 800-634-9961, extension 235. So please, whether I'm not able to get to all of the questions now, or if you come up with one down the road or after this Q&A session, please don't hesitate to reach out to us. We'd be more than happy to help you deal with some of the issues that are out there.
Hello,
Moto. So let's get into the questions. First question that I have here is from Matt. Matt says, a lot of people still use the calcium chloride test. Are they still considered acceptable by code? Well, Matt, there really isn't quote unquote code for this. The code comes directly from the adhesive and the finishes manufacturers that are going to have to warranty these applications or these installations. So at the end of the day, if the manufacturer of whatever the finished product is, whether it's a stone or resilient or carpet or whatever it is, if they accept calcium chloride, then it's accepted or it's acceptable. Most of the time what you'll find now is you'll find that manufacturers will have, at the least, they'll have an either or situation where you can either test with relative humidity or you can test with calcium chloride. And then it becomes the installer's decision as to what they want to physically do as far as which test they want to partake in. I always tell, especially salespeople or technical people, I'll tell them that at the end of the day, it really comes down to understanding what each one of these tests do for the installer or the building owner. Once they really understand what information they are getting from either test, a lot of them realize that if they have the option, they want to go with relative humidity because they understand that that's going to be the testing methodology that's going to help them really determine whether or not down the road there's going to be a flooring issue. Calcium chloride definitely is something that it gives you an idea of what's going on the surface of the concrete right this second, but it really doesn't tell you what the potential is and what's going to happen down the road. So a couple of the other questions that I get quite often are revolve around the thickness of the slab. Obviously, as we've said in this entire video, we've talked about the situation where relative humidity testing is a very depth-specific measurement, and to get the best information, these sensors need to be placed at a very specific measurement in that concrete. And so it always lends itself to the question from a lot of people, how do I determine how thick the concrete is? So there's definitely a black and white way to do it, and the black and white way to do it is there is a device out there that you can use on the surface of the concrete that will send a signal through the thickness of the concrete and help give you a determination of what that mass of concrete thickness is. Unfortunately, although it is quite accurate, it's also quite spendy. Last time I checked, it was about $2,500, and it works in conjunction with your smart device, so your iPad or Android, your Android device. So it really comes down to, are you going to be able to utilize it enough to be able to come up with that? or to be able to justify that expenditure. What I find that a lot of people will do is, especially new construction, they'll look at construction documents, specifications for what the concrete thickness is supposed to be, discussions with general contractors, discussions with building owners. When you're looking at existing slabs, a lot of times you have situations where they're trenching to move plumbing. You may have stairwells for elevated slabs that you can see that there's penetrations going through the second floor or third floor. Usually those penetrations are not cut tight, so you can actually see in between the floor and the penetration itself. So just different things like that. Worst case scenario, one of the things that I hear people doing out there in the real world, they'll take smaller diameter drill bits, pick a couple of places on the floor, they'll drill all the way through the slab. By no means are you trying to turn that slab into Swiss cheese. You just want a couple of comparative measurements. They'll usually take a piece of wire, make a J-hook out of it, push it all the way through the slab. Once it gets down there, they can pull it up, mark it off at the top of the Sharpie, and then you can actually pull it out and see what the general thickness of that slab is, and then make a calculation based off of that. The other thing, looks like I have a question from Sean. Says, is there a maximum lifespan or accuracy lifespan on the probes once they are installed in the slab? So, from a technical standpoint, they're going to last as long as, they will potentially last as long as the certificate of calibration is good for it. On the other side, any sensor that has been in a slab for a duration of time, especially in a slab that has a very, very, very high relative humidity or caustic environment, we will always recommend that when you're looking at those, if you're looking at those for a long duration of time, that you also do additional sampling on top of that to validate any previous tests that were done. Most of the time, if we're going into an environment, and we'll recommend this, if you're going into an environment where you know that the moisture is going to be very high in the slab. In the 12, 15 years that I've been doing this, many, many times people will go in earlier than what is realistic for the concrete to be dry. We know that in those situations that the concrete is going to be very wet. So to go in there and do your entire battery of tests really is a lesson of utility there, because you know that they're all going to read high. So going in and doing sampling at that point to be able to have a baseline to work off of, and then as time goes on and as conditions change that would make it so that the concrete is actually drying more, then you would add some more sensors in there so that you can get a reading and also validate the previous set that you had in there. Also, by having sensors in there for a long duration of time, sometimes things can happen to them being an active work site. So being able to have additional sensors that were set at some periodic duration of time between the different sensors being set would help validate the overall accuracy of all the sensors. Another question that I get a lot revolves around slabs in elevated situations. So if we're talking about a slab that is breathing from two sides, a structural slab, exposed on the top and exposed on the bottom, then the depth in that slab that you're going to drill the hole is only going to be 20% of the overall thickness. If you have a slab that is poured into a pan deck, the overall thickness or the overall depth of that hole is going to be 40% of that thickness. At that point, then the question becomes, okay, are we talking about, because again, in pan decking, you have thin areas and you have thick areas. Question becomes, do I calculate based off the thin area or the thick area? So the first thing I say is that the ASTM standard does not have an absolute answer to that. On the other side of it, what we recommend is that you do the best you can to identify where the thickest areas are, and that you calculate and place sensors in those thickest areas, but calculate your hole depth based on what that overall thickness is. So most cases, or a lot of cases, you have a thin area that's 2.5, thick area that's 5.5. You calculate 40% of that 5.5 inch thickness, and then identify where that 5.5 inch thickness lays in the floor. A lot of times you'll have people that will either do it based on a either drilling pilot holes so that they can identify where those deep troughs are at, or there is a, what I call, or at least as far as I'm concerned, fairly inexpensive metal detector, which works a lot like a stud finder in a wall. It helps you to scan across, and it scans deep enough to pick up the high points in the metal pan decking. So you can scan across, find that, scan across, find the other one, and then you know in between those two spots is where the overall thickness of the, or the deep thickness is at. Not perfect, but it's definitely something that you know, a lot of people have found is a lot better than trying to drill pilot holes and identify where you're at and then measuring off of those. So it doesn't look like there's anything else that we have here as far as questions. Again, my name is Jason Spangler. My direct contact information or phone number is 800-634-9961, and it's extension 235. Thanks, and have a great day.